Hi, and welcome to your first geometry video on points, lines, and planes. We're going to start off with our building blocks for the rest of the year, and those include our 3 undefined terms of geometry, and then I'm going to proceed to define each of them for you. Okay, so the first term is a point, and that first undefined term has no size, but it represents location for us in space, which is the grander scheme of things. We denote points with a capital letter. This is a picture of point A, point B, and point C. And I want you to take note of the fact that there's no symbol for a point when writing a sentence, okay? So if I want to write about point A, point B, and point C, I have to use the actual word. This is going to be important to you, you'll see in a second, because we do have symbols for most of our other objects. Okay, so points, again, technically speaking, have no size, but we represent them with a dot in a picture. Okay, lines are the next undefined term of geometry, and lines, you get lines by putting together a bunch of dots next to each other, and you end up forming a line. Lines are infinite in 2 directions, okay? There's no thickness to lines, okay? Lines have no thickness. And when we name lines, we use one of 2 things, either a lowercase script letter like this one, this would be line K, or we pick any 2 letters on the line, in this case we only have 2 letters, and we call the line by those 2 points. So this would be line AB, or we could have also called it line BA. And just, again, any 2 letters, any order, because it is infinite in both directions. And don't forget to always put your arrows on the end. Okay, our next term, vocabulary term, is collinear. Collinear describes points that are on the same line. So for example, if we drew the picture of a line, let's just say A, M, and Z, then we would say that in this picture, points A, M, and Z are collinear. Points A, M, and Z are on the same line. By the way, can you give me 2, let's say 3 other names for this line? 3 other names for this line. Take a second, think about it, stop the video so that you can write down those 3 names or take a guess at them. Okay, hopefully you're back now. And 3 possible names could have been line AM, line AZ, and then let's just say, for argument's sake, line ZM, okay? Those are 3 possible options. There are several others. So again, if you doubt what you have, show it to me in class and we'll see how you did. The last thing on this page is non-collinear points, which of course is points that are not contained by the same line. So for example, if we drew this picture of this line, and by the way, what would the name of that line be? Hopefully you said line CR or line RC. And then we went ahead and put a point B here. So we would say points C, B, and R are non-collinear. Okay, because there is not one line that can grab all 3 of those points at the same time. Okay, we're going to go ahead and move on to page 2. Okay, so on page 2 we have our 3rd undefined term of geometry, and that is a plane. And I didn't use it on the first page, but we're going to use it now. Let's use a highlighter to mark those words. You should probably go back to page 1 and highlight all of your vocabulary words on that page. So number 3, undefined term, again, is a plane. A plane is what happens when we take a bunch of lines and we start stacking them together and they would again form a solid plane. For example, there's a set of lines forming this piece of paper. Okay, so planes have no edges, okay, but if we did not put edges on them, then we would not be able to see them on our paper and represent them on their paper. So what we're going to do is, for the shape we use for planes is usually a parallelogram, and then we label them with a capital letter. So you can see here, this is plane M. Okay, this would be a horizontal plane, this would be a vertical plane. I am never going to ask you to draw one type or another. You'll see in class most of the time I draw horizontal planes. This is a picture of two planes intersecting each other. Notice the dashed lines are to show where intersections are occurring, but they are hidden from your view, or where sides are hidden from your view. So in this case, this dotted line is showing us where the two planes are crossing each other, yet again, we know we would not visibly see that intersection. Over here, the other way that you can name planes is with three non-collinear points, and you can see that we could call this guy plane ABC because these 3 points are non-collinear. One quick reminder at the bottom here, when drawing in planes, stay off the edges of the plane. I will bring this up in class when we go over the examples, but you want to try. So for example, let's say I ask you to draw, put point D, for example, in plane ABC. Well, I would want to put point D in the plane. I would not put point D on this side because, again, planes don't necessarily have sides. We just draw them so that, again, we have something to see. Okay, so keep that in mind. Okay, a couple more vocab words at the bottom here. Coplanar is describing points contained by the same plane. Non-coplanar are points that are not contained by the same plane. Okay, some simple vocab words, and again, we will end up discussing those more in class. And then, of course, as you can see, we started with points. We use points and put them together to make lines. We use lines and put those together to create planes. And now, if I went ahead and stacked a bunch of planes together, what I end up creating is space, the set of all points. Again, we will go over that. And how many points are in space? Infinite points are in space. So keep that in mind. Okay, we're going to move on to page 3. Okay, here we are on page 3. And the first vocab word is intersection. It's the set of points that two or more figures have in common. So make a note here that intersections can be points, lines, planes, segments. Okay, keep this in mind. Intersections can be a lot of different things. So postulate or an axiom is a statement that is accepted without proof. Okay, so we just take it at face value. We don't argue with it. We just, again, accept it and use it. Okay, so here are a few postulates that, again, statements we're going to accept without any proof. So through any 2 points, there is exactly one line. Picture it, if you will, point A and point Z. There is only one possible line that I can draw through those 2 points. Second one, if 2 distinct lines intersect, then they intersect in exactly 1 point. So again, picture it, if you will, that your 2 lines are crossing each other. And when those 2 lines cross each other, of course, their intersection will be a single point. The third one, if 2 distinct planes intersect, they intersect in exactly 1 line. If you go back to the picture on page 2, you will see that Here are two planes crossing. The intersection would be right here. It would continue forever because these planes would continue forever, and your intersection would be all the points that are on that line. Okay, back to page 3. And then the last one, let's put here see picture on page 2. And the last one here says through any 3 non-collinear points there's exactly one plane. And again, if you look back on page 2, you can see this picture with points A, B, C. There's exactly one plane that contains those 3 points. There's no other plane that could describe it. Okay, so let's put here also, see the picture on page 2. Okay, so we will continue from here. We'll work on these examples in class. If you want to, I highly recommend, why don't you try right now to show me in class? Why don't you try A? And why don't you try B? See how you do drawing those pictures and labeling them, and I will see you in class.